Okay guys, so I'm going to look at a curve now, and I'm going to look at a graph, and given the stuff that you learned and the stuff that you know, because you guys are good students, mashallah, right? Do you notice this thing over here? Right, I've got the x-axis and I've got the y-axis. And now I'm going to draw a curve, and this curve looks like that. Are you with me? Okay, so if we look at this curve, people, I need you to tell me, if I call this point here x, that's corresponding to a specific x, right? And I call this curve f, oh mama, and I look at this, what's the corresponding y point here? F of x. Are you guys with me? Right? Now I need to ask you guys something. This point here, that's my second x value. If I tell you that I'm looking at this distance between these 2 points being h, then what is that thing there?
That thing is h plus x.
Right?
H plus x.
Or h plus x. Do you agree? Because if this, for example, is 1 and this distance is 3, then that must be 4. And how do you get 4, Mahir? 1 plus 3. Are you sure?
Therefore x should be 3.
Okay. But that's exactly what I did. Okay. So the corresponding y value here is what? F of x plus a. Okay. So the corresponding y coordinate there. Now you guys all know that if you want the average gradient, which I'm going to draw over here, it's just the gradient of the, oh mama. The gradient is just the gradient of the straight line that joins those 2 points. Do you agree with me?
Yes.
Do you see that? Then you take the point there and the point here. And then what's the gradient going to be? F of x plus h minus f of x divided by x plus h minus x. Do you all see that?
No,
okay.
I don't say.
Now, so guys, very clearly I'm not going to talk about average gradient, because if I want the average gradient of the blue curve, I simply find the gradient between f of x plus h and f of x, right? Over x plus h and x. Do you guys all understand that? It's what we done in the previous slide here. Do you see this? Those are your coordinates. There you go. But this thing here represents, does this represent the gradient at a point? Yes or no? No. It represents the gradient between these 2 points. In fact, it represents the gradient of this orange line. And when you look at the orange line, the gradient at any point is equivalent. But for the blue curve, the gradient is not the same everywhere. Do you all agree with that?
Yes.
Okay. Now, Mahir, I need you to pay very, very careful attention here. Let's choose sky blue. Let's say I'm going to move that point here. Right? And I go down here. And I call this distance E. I'll make it, what's the letter before G? H. E, F, G. So it's G. Sorry, I answered my question there already. So if I look at that, this point here will be f of x plus Can you speak up, guys?
F of x plus.
Right, f of x plus g. Now what has happened to that distance h when it becomes g?
It decreased.
It became smaller. It decreases, right? Now guys, then I can find the gradient. Let's make it a violet line between that 2 points. Do you see that?
So it's a different slope now.
It's a different slope. Do you see that? What if I decrease the distance further and I take a point here?
So
I take a point there. Okay, I'm going to take the line out, but I'm going to draw a line there. I'm going to make that line brown as well. If I'm interested in that point there, what happens to the slope? It decreases, right? In fact, now it's actually become negative. Okay, and what has happened to that distance that we spoke of here between that point and there? Right? If that distance is now f. Now guys, what am I doing with the 2 points? I've got 2 points. Do you see? The one is here by x plus h and the other one is there. And as I move the secant line, this line that joins 2 points is called what? A secant line. As I move that secant line, What's happening? What's happening to my 2 points on the curve? Mahir, what's happening to my 2 points on the curve? Yeah, it's changing. How's it changing?
Decreasing.
The distance between the points are decreasing, but what's happening?
It's going to a negative.
No. The gradient is
Okay. So we have this person here and that person there, right? Yeah. What's happening? They're moving closer to one another. They're moving closer to one another. So your 2 points were far apart, joining a secant line, and you have an average gradient. When you bring the points closer together, what's happening to my distance between the 2 points?
decreasing.
They are decreasing, right? They are decreasing. And what happens to the value between them as they get closer and closer to each other? The distance between them, besides decreasing, it's tending towards zero. When will the distance between them be zero?
When there's only 1 point.
When they are on top of each other. Okay. Now, very importantly, guys, that's the idea that we're working with. But the moment you put 2 points together and they are on top of each other, do you really have 2 points now?
No.
You have 1 point. But we said that is a
That is secret.
That is impossible.
No. That is a thingy.
Problem.
That is a problem. Right, that is a problem. But we now need to take the 1 point and do what with it? Treat it like it's 2 points. So in other words, these 2 points are going to come closer and closer, right? Until they we want them on top of each other, but if they are on top of each other, that is a problem. So you want them likely on top of each other, but not completely on top of each other. You want the distance to decrease. Okay? And that brings us to yesterday's thing. So do you all agree with me, if I have to draw up a formula for the gradient here between f of x plus h and f of x, the gradient formula is f of x plus h, are you all with me? Minus f of x, yes? Over what? X plus h minus x. And then this part cancels out, do you agree? The x and the minus x, right? But that's us bringing 2 points together, bringing them on top of each other, and that creates a problem. So you want them infinitesimally close. You want them as close as possible, but not really touching, which gives you the what?
The gradient of the specific.
The infinite.
What did we do yesterday?
The problem.
It gives you a limit. So what we now do is, all we do is we take the word limit and we put it in front there to say we want h to become as close to 0 as possible. And this here is the... So the reason we've introduced the limit here is because we're bringing the 2 points as infinitesimally close as possible. But the moment you put 2 points on top of each other, what happens? Say again? You can sort of make a line. That's the other thing I'm going to get to now. What happens here, guys, is if you put them on top of each other, they are 1 point. So they're the same point. So what we're saying is we've constructed this on the basis of drawing the distance to 0. Right? But don't let the distance truly be 0. Let it be 0, comma, a million, trillion, billion zeros, 1. For example. You're zooming into the infinity level. That's what we're saying, which I'm going to show you next. So guys, this is a gradient for 2 points. But we're saying bring that points as close as possible. But don't let them sit on each other. And that's why you have a limit. Okay? So guys, given that we've now discussed that, and we've looked at drawing these 2 points infinitesimally close, having the value sit on top of each other, okay? But without really touching, that's where the limit comes in. We now have defined what we call the derivative. This here is called a derivative. Now when you do the derivative, if the 2 points sit on top of each other, I'm going to bring up a sky blue line. And I'm still working with that point over there. Right? If I have to draw a line through that point, and it only touches at a single point, it is no longer what we call a secant line, but it becomes a line called a tangent line. Are you guys with me? This line here is what? A tangent line. And this formula that's written over here is the formula for the derivative. Are you guys with me? Okay. Do we all understand what happened with this gradient now? It used to be the gradient of the secant. Now this derivative is essentially the gradient of the tangent, because we've taken 2 points, and what do we do with the 2 points? Infinitesimally close,
But not.
right? Right? As close as possible. Are you guys with me? Okay. Right.